we do have, carefully you should see the block diagram, we do have one input here, the other input here, whereas this is the output. Therefore, R of S and N of S is inputs, where Y of S is the output. Now, the transfer function will now be two different transfer functions that you get. One is Y of S by R of S, whereas the other one is N of S by Y of S. Sorry, output by input, right? So the other one would be Y of S by N of S. So when I am calculating, when I am trying to solve Y of S by R of S, I will try to assume N of S to be equal to 0. This is what you do when two inputs are given. I think rule number 10 in the rules discussion that we did. Similarly, Y of S by N of S, we will consider R of S to be equal to 0. Okay. So therefore, we are now should find two different transfer functions by assuming one of the input to be equal to 0. So here, if I assume N of S to be equal to 0, the block diagram would be, now once N of S is 0 here, so we do have only one input for the summing point. Therefore, I can remove this summing point and directly give this line to this line. I can connect this line to this line because only one input will be there. So whatever comes here will be this. Therefore, I can directly connect this line to Y of S when N of S is 0. Therefore, I will just do that here itself. I will just remove this and I will just say direct connection. It means when N of S equals 0. Now, this is the block diagram which we have with us now. Now, we need to now reduce this block diagram to find out the transfer function Y of S by R of S. So, how will we do that? So, here if you try to see the block diagram, I can somehow simplify this, but I do have another path which is connected to this. So therefore, it's always better to move this block behind this summing point. Okay, move this block behind this summing point. Now if I move this block behind the summing point, this used to come here and gets multiplied by S plus 2. Now if I move this block behind the summing point, then this particular feedback will never get multiplied by S plus 2. So what we do is, we will try to remove this first, okay, and I will try to add this block here. I am just doing it in the same diagram where you can write a separate diagram for this. So S plus 2 is here, okay, this is R of S, and this whatever we had, we'll try to go to this point only, okay, whereas now this will be connected directly to this. Okay, was that the connection? Let me see. I think it is better we'll write the separate diagram itself, because we'll lose the initial connections that we had. So it is better we write the separate diagram. Fine, don't get confused. So I'll have R of S with the block S plus 2. Now this is R of S. Now this is coming to a summing point now. Fine. Now this is connected to another summing point now. Now this is coming from this position now, which is 2, which will be connected to this. Fine. Now this will remain to be 10 divided by S into S plus 1. This will go to Y of S now. This will remain to be 0.5 S, which will again get connected to this. Now what about this? This is which is very important. What happens to this? This was coming here. When it was going here, it used to get multiplied by S plus 2. but you have shifted s plus 2 behind the summing point now. Therefore, this will now get multiplied by s plus 2. Now it is fine. So this used to come here and it used to get multiplied by s plus 2, where now I have replaced this unity feedback with s plus 2. Therefore, s plus 2 is coming here and it is going here. So it is fine, one are the same. Okay. So, and even r of s used to get multiplied by s plus 2 because r of s used to come here. So this was something like r of s minus 1 into s plus 2. R of s minus 1 into s plus 2. So here r of s into s plus 2 minus 1 into s plus 2. So one are the same. So same thing we get here also. You see, if I say what is output here, it is r of s into s plus 2 minus s plus 2 into 1. So that will remain to be same, this only. Okay. So now, as we have two summing points here, I can just interchange the summing points because all are summing points here. So therefore, I can change the interchange the position of the summing points, or I can just change the position of these feedback paths, either giving here or giving here. It is one and the same. This also, instead of giving here, you give it here. It is one and the same. So therefore, s plus 2, I have a summing point here, and then I'll have another summing point here. So here I'll give 2 to this point now. Okay. So instead of giving here, I gave 2 to this block. So this is plus and this is plus. So here it is plus, plus, and this is minus. Okay. Now I'll split this summing point into 2 different summing points. Splitting this 3 input summing point to 2 different summing point. Okay. Where one summing point will receive this one, which is s plus 2. Okay. The other summing point will receive this 0.5. It is all same. I am just splitting 2 summing points to 3 summing points, and meanwhile I am changing the position of the paths. So it is like x plus y plus z is also equal to y plus x plus z. Irrespective position of x, y, z, all 3 are getting added up, therefore it is one and the same. So this is 0.5s. Okay. So therefore this is minus, this is plus, this is plus, and this is r of s. Now the job is simple. Now these both are in parallel. This is in feedback path. Okay, so you can just reduce that first. So what will I get? R of s going to one single block now, which is 2 plus s plus 2. So I'll just say it is s plus 4. Because they are parallel, so they both get added up. So it is s plus 4, giving to a summing point, and this is given to another single block, where this is in the feedback loop. This is feedback loop. Therefore, I'll just solve it first and then I'll write that here. So it is 10 divided by s into s plus 1. So here this is g, this is h, divided by 1 plus because it is minus negative feedback, 1 plus 10 divided by s into s plus 1 multiplied by 0.5s. So which will be equal to, you take s into s plus 1 LCM, therefore 10 divided by s into s plus 1 added with 10 into 0.5, which is 5s, which is equal to 10 divided by s square plus 6s. So I'll just write that here, 10 divided by s square plus 6s, and then we'll have y of s, and then you will have another loop here which is s plus 2. Now if you carefully see, this is now again a feedback path. Again it is a feedback path. Therefore, it is again 10 divided by s square plus 6s divided by again 1 plus, because negative feedback. Now this is g, this is h, 1 plus 10 divided by s square plus 6s into s plus 2. So that is h value. Okay. So therefore, what will I get? I will just take s square plus 6s as LCM, 10 divided by s square plus 6s plus 10s plus 20. So I will be getting 10 divided by s square plus 16s plus 20. So that would be the block which will be replacing it. Therefore, R of s is the input, s plus 4 is the term where we will now be getting a single block which is 10 divided by s square plus 16s plus 20, and this is y of s. Okay. Now finally you see these both are in series, therefore the total y of s by R of s is equal to 10 into s plus 4 divided by s square plus 16s plus 20. Okay, so this is the final transfer function that we get for this particular problem when input n of s is equal to 0. Okay. Now let's see what is y of s by n of s input when R of s is equal to 0. Now when R of s is equal to 0, R this 2 is getting multiplied by R of s, this 2 is getting multiplied by this R of s, and then it is given to this particular summing point. Now as R of s will become 0, therefore this 2 into that 0 will also be equal to 0, therefore I can completely remove this entire block. I don't need 2 also, because when R of s is equal to 0, anything multiplied by 0 is again 0, therefore I can remove this complete 2. Now this would be the block which you can see here. Now when you carefully see that this is 1 unity feedback, this is actually 1. Okay, so this 1 multiplied by minus 1 is coming here, we don't have anything here, therefore minus 1 multiplied by s plus 2 would be minus s plus 2. Therefore I will remove this summing point, I don't need this, and I'll just multiply s plus 2 with negative sign, so that would be the total block. So therefore this complete I'll remove, and then I'll say this is s plus 2, this is s plus minus of s plus 2, and this is given to this. Okay, so now you see this 0.5s and minus of s plus 2 both are coming to the summing point, both are arriving to the summing point. When both are arriving to the same summing point, can we say that 0.5s is parallel with minus of s plus 2, right? They both are coming meeting at the same summing point, then I can say that the point s is parallel to this summing point. Therefore I would say this complete block whatever I have, will now be replaced with a single block which is minus 0.5s, because negative is there, added with minus of s plus 2, which is minus 0.5s minus s minus 2, which is equal to minus 1.5 times s minus 2. Therefore, I'll just erase that here. I'll just erase it here only, and I'll replace this complete block which is connected with the term minus 1 point. So I'll have a single block now, which is minus 1.5 times s minus 2. Finally, you see that these two blocks are in series. These two blocks are in series. Therefore, I can easily multiply that series blocks. 10 divided by s into s plus 1 multiplied by minus 1.5 times s minus 2. So I would say, which is equal to 15s plus 20. So I'll just take negative outside, divided by s into s plus 1. Okay. So therefore, I'll try to write a new block here. So I will have a summing point here where n of s is the input, which is positive. I am getting a block here which is nothing but 15s plus 20 divided by s into s plus 1, and I will represent this negative here. That can be done, and this is given to the point here, and this is n of s. Okay. Now instead of writing the block in this way, I'll just write in a different manner. Let me show you. So I have a summing point here. N of s is coming as an input, which is positive. Now I do have an output. I do have an output n of s here. Sorry, this is not n of s. Y of s. I do have an output y of s. I do have an output y of s. Now here, from this y of s, here from this y of s, this is going. Therefore, it is reaching here, which is negative, and it is given to y of s, which is 15s plus 20 divided by s into s plus 1. So now again you see this is the complete feedback loop. Therefore, I can say g is now equal to 1, whereas this will behave as h. Therefore, the final transfer function y of s by n of s is equal to g is 1 divided by 1 plus, because negative feedback, 15s plus 20 divided by s into s plus 1, which is multiplied by 1 into, because g is 1 into h, which is now equal to, I'll take LCM. So when I take LCM, this s into s plus 1 will come to the numerator. So I'll say s into s plus 1 divided by, this s into s plus 1 multiplied by 1 is s square plus s plus 15s plus 20. Therefore, finally you see that y of s by n of s is equal to s into s plus 1 divided by s square plus 16s plus 20. So this is the answer for the second transfer function, y of s by n of s, when r of s is equal to 0. When r of s is equal to 0. So I hope all these block diagrams which I have discussed with you, and the block diagram reduction techniques which I have applied for all the block diagrams, for all the problems which we have solved, at least you are clear with how to solve the block diagram, and you are clear with how to write the block diagram for any given electrical network, and find out the final transfer function by reducing the block diagram step by step. So how to reduce it is all depends to you, because it's like a puzzle. You have to think, you have to see the block diagram more than 1 or 2 times, and you have to think which technique should be applied so that the reduction will happen and the block diagram gets simplified. So don't end up in applying some techniques and making the block diagram to be complicated. That is very important. Okay. So once you apply any technique, you should see through that the block diagram gets reduced and it becomes in the most simplest manner so that you can find out the solution at the end. Okay. So therefore, I hope this video helped you in learning block diagrams, and I have also solved the last problem with 2 inputs and 1 output, which made you to learn even finding out the transfer function when you have 2 inputs in any block diagram. Fine. So in my next video, you will see how to solve signal flow graph and how to find out the transfer function using signal flow graph by applying Mason's gain formula. Okay. Thank you.